Hello Hopewell, this is Day 7 Notes, Chapter 10.4. The goal for today is we're going to solve radical equations, equations with square roots, and a variable underneath the radical. In order to be able to do this, we have to remember we've solved lots of equations this year. We've solved linear equations like exercises 1 and number 2. We've solved quadratic equations like exercises 5 and 6. We've squared monomials and squared binomials, so this will encompass a lot of prerequisite skills that you'll need to know for today. By the end of class, we're going to, again, solve equations with variables underneath the radical. To solve any equation, we're going to reverse order of operations. So for the first two exercises, they both have an x to the first power. This one has two x's to the first power. Both of these are linear equations. The goal for solving a linear equation, get the x's by themselves, get the numbers on the opposite side, and make sure you get the x completely isolated. There's only one x here. We have a minus 5, so we're going to add 5 to both sides. This is called collecting like terms. When they're on the same side, we combine the like terms. Negative 22 plus 5 is negative 17. The x is isolated. It's by itself. There's no other steps to do. That is your first answer. In exercise 2, this is a little different because there are x's on both sides. The idea is the same. You want to get the x by itself, but when you have like terms on opposite sides, you want to move them together. I always move the x's first, just in case there's no solution or all real number solutions. That might be helpful a little bit later. So I'm going to move all my variables to the left. Negative 2x is on the left-hand side. If the x's go to the left, that means the 42 is going to go to the right. I'm going to add 42 to both sides next. So negative 2x is on the left. On the right-hand side, I have negative 8 plus 42. So that's positive 34. The x term is by itself, but there's a negative 2 multiplying it. So we're going to divide both sides by negative 2. The negative 2's cancel. Now I have x equals negative 17. Exercises 3 and 4, you're still solving equations, but these involve exponents, so we do those completely different. Before we get there, let's square a monomial and square a binomial. When you square anything, it means the base multiplies itself. So we're going to multiply 4 times itself and x times itself. So you're going to square 4 and square the x. 4 times 4 is 16. X times x is x squared. So we have 16x squared. When we multiply when you square, you multiply the base times itself. What is the change that we need to do when it is a binomial? We can't square both pieces. What we'd have to do is FOIL or box. So I'll do a small box here. We are multiplying x minus 5 times itself. So along one of the edges, I put an x minus 5. Along the other edge, we're going to do another x minus 5. Top left box, x times x is x squared. Top right box, x times negative 5 is negative 5x. Bottom left box, negative 5 times x is negative 5x. Bottom right corner, negative times a negative, 5 times 5, positive 25. We have any like terms along this diagonal? We do. We have two linears, but first we start to write the quadratic term, x to the second power. Then our two linear terms. Then our constant term at the end. Our final answer is written in standard form, x squared minus 10x plus 25. There is a shortcut method, but I'm not going to show you. Exercises 5 and 6, we're solving quadratic equations. We learned several ways to do this. Sometimes we solve them by square rooting. Sometimes we solve them using a graph. Sometimes we solve them using factoring. And other times we solve using quadratic formula. Because it says factor, we're going to do the factoring. The value of c is negative 24, so we want the last two numbers in our factors to multiply together to make negative 24. Those two factors also have to add up together to make negative 5. We write our factor pairs in order, starting with negative 1 and 24. They multiply to make negative 24, but when they add up to make 23, so we're going to keep looking. Negative 2 and 12. When they multiply, they make negative 24. When you add them, they make 10. Keep looking. Negative 3 and 8. They multiply to make negative 24, and when they add together, they make regular positive 5. So we're close. We have the right numbers, but they have the wrong signs. We're going to switch both signs. So the 8 becomes negative, the 3 becomes positive. They multiply to make negative 24. They add up to make negative 5. So let's go back and factor the left-hand side. The first pair of terms that multiply each other have to make an x squared. That's x and x. The last two numbers have to do two things. They have to multiply to make negative 24, and they have to add up to make negative 5. So we have negative 8 and 3. Those are the numbers we found in our t-chart. The next step we need to do is continue. We're going to split this. The first equation we're going to write is x minus 8 equals 0. The second equation is x plus 3 equals 0. We're going to solve. X equals positive 8 is one answer, and x equals negative 3 is your other solution. Number 6 is a little bit easier. There's an x that's being squared. To get it by itself, we could just undo the square. What is the inverse operation of squaring? Square rooting. Squaring and square rooting are inverse operations most of the time. When you square root x squared, that makes it an x. When you square root 25, that makes 5, but I think I remember this is a little bit more tricky. The square root of 25 is 5 when I put it in my calculator, but I feel like there's going to be two answers. Negative 5 to the second power also equals 25, so I have to remember to put a plus and a minus in front of the square root of this 25. There are two answers. They both make sense. All of this is the prerequisite skills that will enable us to solve our equations involving radicals. The first step of doing this is to make sure that the radical term is isolated or by itself. So before we do anything else on this page, all we are going to do is we're going to determine, are these isolated or not? Are these radicals isolated or by themselves or not? And then if they are not, we're going to isolate them. So let's take a look at exercise 1. Is this square root by itself? Is there anything in front or behind it? This one is isolated. It is by itself. Let's write isolated. Exercise 2. Is this square root by itself if it has a plus 32 next to it? This one is not isolated. Go ahead, pause the video. Determine if these are isolated or not isolated, and then unpause it when you are done. We're back. The square root of x minus 2 has a 3 in front of it. Is it isolated? No, it's not isolated. And how about number 4? The square root of x minus 4, nothing in front, nothing behind it, just the equal sign. So yes, number 4 is isolated. For the two exercises that were not isolated, how do you get rid of each of these extra things? You would subtract your 32. Now you would have the square root of x equals 6. Now that is isolated. And when there's a number in front, that's multiplying, so we're going to divide. The square root of x minus 2 equals 12. You would have to keep going, but we're going to do this on the next page. We're going to practice solving on the next page. On this page alone, I just want in this first part of this video to isolate all of the radicals. So none of the next 6 exercises have radicals that are isolated. Our job is to isolate those radicals using inverse operations. In exercise 1, the square root of x has a plus 8. To isolate it, we're going to subtract 8 on both sides. The square root of x equals 7. Now it's isolated. Let's go on to the next one. The square root of 2x minus 3 is being subtracted by a 4, and it equals 16. That's not isolated, so we're going to add 4 to both sides. Square root of 2x minus 3 equals 20. Now the square root is isolated. The 5 in front of this radical is multiplying, so we're going to divide both sides by 5. The square root of x equals 9. Now this radical is isolated. We don't know what the answers are. We're not going to solve these equations until our next page. The bottom section, our square root of 3x minus 22 is being subtracted by 5, so we're going to add 5. The square root of 3x minus 22 equals 20 again. All right, what happens in exercise 5? The square root is being multiplied by 3 and added by 9. The first thing we're going to do is minus the 9. We always reverse your order of operations. So we undo addition and subtraction before you undo the multiplication. Now that the 3 is the only thing in front of this radical, now we can divide, and we have the square root of x over 3 equals 2. This radical is now isolated. Moving on to the last exercise. Here's your square root. We're going to first undo the addition with subtraction. We're going to subtract like terms. The opposite of the square root of x plus 3 equals negative 3 minus x. The last step we're going to do is divide everything by -1, each term separately. Everything negative is going to turn positive. The square root of x plus 3 is equal to, you could write 3 plus x, but I rather write it as x plus 3. The first part of solving an equation with a radical and a variable underneath it is to isolate the radical. If there are terms added, subtracted, multiplying, or dividing your radical, you have to undo the operation to isolate the radical. We'll find out how to solve each of these equations in the next page. Watch part 2 of this video.